Recovery is the foundation for life cycle refrigerant management, as without safe refrigerant recovery, there cannot be reclamation or reuse. A-Gas Rapid Recovery is an on-site refrigerant recovery service that gives businesses an easy way to contain their used refrigerants.
Not a whole lot of companies do what we do. We handle some of the grunt work that they don't want to do, and we can do it 10 times as fast as they can. The recovery portion, the cylinder exchanges, and buying back used material that otherwise can't be used.
We play a big role with our contractors, whether that be HVAC, mechanical, or demolition contractors. Our whole purpose is to get on site and not only help them save money in the project, but offer an environmental solution.
We do not want any of these products getting vented to atmosphere, no matter how low the GWP is. Now it's not only the cylinder to recover the product, but it's making sure that technicians have equipment that are rated to work with flammable gases. That's really important for people.
So by us being able to contain it in the cylinders, reclaim it, we're saving the environment one recovery at a time.
My name is Mike Idle. Today I wanted to give you an overview of Amatrol's T7300 HVAC control system. This system is designed to align a hands-on workstation, as you see here, along with interactive curriculum to teach the operation, installation, application, and troubleshooting of control systems related to the HVAC industry. As components and features of HVAC systems get smarter in both the residential and commercial fields, it's important for current and future HVAC technicians to be trained up. What types of circuits are used, familiarity, learning, operation, maintenance, troubleshooting are all important areas to cover in that.
Here at NAVAC, we are obsessed with delivering the best HVAC tools on the market. Our tools are built for professionals and engineered for precision, just like Harley-Davidson motorcycles. NAVAC Nation, it's time for you to feel the power both on and off the job site. Let's stand up in our pursuit of perfection. From coast to coast, NAVAC forges the path forward. Wherever you are, we will be right beside you.
Hello, everyone. Thank you so much for joining us once again on Did You Know, the ESCO HVAC show. So today we are actually out on the road. Jocelyn is manning the computer here for us. She's going to be watching the chat. And by the way, everyone is joining. Let us know in the chat where you're joining from. Love to know, what do you need from us? Going into the new year, we want to make sure that we're getting all of the content that you are needing in the classroom, in the field, wherever you are. So we're going to be spending some time with Ken Monis and Donnie King from RectorSeal. How you doing, guys?
Good. Thank you for having us.
Yeah, no, this is great. We're actually at the DC, the distribution center here in Greenwood, Indiana. So it's not very far for Jocelyn and I to come over. So we brought the trailer with us. We're hanging out. We're going to dive into a topic that is very important and often gets overlooked when we're doing education or even as contractors talking about proper system designs. And let us know how we're doing, especially with the audio. We had to, we were a couple minutes late because we were resetting some audio and camera clips. So things are coming through. Let us know for sure. So it really comes down to thinking about proper airflow. We spend a lot of time talking about inverter-driven systems and two-stage systems. We start talking about high-efficiency technologies. We're requiring a lot of airflow in a lot of our new systems. And it goes back to conversation that Ken and I were having before the show. Probably 15 years ago or so, I was doing a remodel on an old farmhouse. And this was before I really understood airflow well. I was a growing technician. And so we were doing a remodel, a lot of hardwood floors. And we were deciding, what we're going to do for registers. And at the time, we were looking at some really fancy oak finished registers for the floor. And my father-in-law at the time that's how I got into the industry. I was working for a family business, and very wise man. He said, you really ought to take a look at the airflow across those fancy looking registers that you're looking at.
Absolutely.
And then you'll come back and rethink about things a little bit.
Yeah.
And so I learned along the way a lot about airflow, a lot about designing systems. I got pretty decent at building duct design, but we often forget about the airflow side coming out of that ductwork and the restrictions and the quality and the selections. And there's a lot of products. And so I thought maybe we'd spend some time today diving into that. So let's talk a little bit about the history of RectorSeal, and especially with the acquisitions of some of the metal products that you're now working with.
You wanna-
Sure. So the history of RectorSeal, we've been around for several years. I joined the company about 8 years ago, and at the time, was selling just HVAC products here in the Midwest, and we've morphed into a more unilateral company where I now cover plumbing and HVAC.
Okay.
And it was, we were having a good time, and then we get a call one December that says, "Hey, you need to get on a call where we've got something happening." And what happened is we purchased True Air.
Right.
And at the time, it was the largest single acquisition that RectorSeal had. It basically doubled our book of business.
Wow.
And it brought us into some products and some applications that not everybody who on the team was familiar with.
Sure.
It has been a fun little journey. We did that for about a year, and then as the joke went, every December we buy a GRD company. So the following December we purchased Shoemaker,
Right.
which is a local, domestic producer. They headquartered up in Cle Elum, Washington, and so we've been in the GRD business now for about 5-6 years. I guess it's 2026 now, and have been successful. Having a really good time with it. Training contractors, training distributors, getting them out on the road.
Yeah.
Ken's probably got some really good history on the True Air line.
Yeah.
He's been there for a while.
Let's go ahead and grab the mic if you don't mind, guys, just to be able to make sure that we keep our audio a little closer for us.
Okay.
And, it's very good. Yeah, definitely. I'm sure it'll come through better. I mean, we could get a good one between the two, but if we pass it around, it'd be really good. Brings up a good question. Heard an acronym in there. We get a lot of acronyms in our industry, and we don't always understand what they are. So let's start with that.
All right. So GRDs.
Yes.
Grills, registers, and diffusers.
A whole
What it
classification.
A whole classification of air devices.
Yeah.
Yeah. Sometimes you'll see it as RGD.
Yep.
Which is a little confusing, but to me, GRD makes sense because, you start with a grill, which is just basically a covering of a outlet or inlet.
Okay.
And then for a register, you take that grill and you add a damper to the back side of it.
Oh, yeah, sure.
Right. So to me, it's GR. And then the D is a diffusers. Diffusers typically go on the ceiling. They can be round, square, rectangular, but they disperse the air in multiple directions, multiple planes. So
Okay.
that's kind of the definition of the three.
All right.
So,
Before we get into doing some examples of what we're talking about and proper selections and differences in products, we've actually got a really exciting thing going on today. So we are going to be raffling off some tools. So we're going to be working with the ProFit series, which is a fantastic product line from RectorSeal. So in the chat, you can do one of two things. You can put your email in the chat, or if you don't want that to be out there for everyone to see your email, go ahead and email it to me directly at cbeck@escogroup.org, and we'll do a raffle, and we'll do a random raffling for that. If you're an educator, because we want to make sure that this gets into the hands of a school. So if you're an educator out there, let us know, and we will make sure that the winner of the raffle gets that, and we'll do a social post on that. So be looking forward to that. So let's start out with some fundamentals. Let's start with the R side of things.
the R side.
Because an R is not just an R. I mean, we have to think about what are we doing with that register?
Correct.
Right?
Correct. Yeah. And in the industry, grills and registers a lot of times are interchangeable.
Yeah.
Terms that contractors will use, and they really aren't. That a grill is just a cover. A register has a damper on the back.
Okay.
Now that damper, it can be used for metering the actual airflow coming out,
Right.
or it could be like the homeowner just wants to shut that room off.
Right.
Or
Isolation.
redirect the air
Yeah.
in a downward or upward pattern depending on where the register is located.
Okay. So where do I begin? Like when I'm thinking about my selection, what factors should I be looking at in my design?
So when you start your selection, the Air Conditioning Contractors of America, ACCA,
Yeah.
they have some recommendations in their Manual D.
Yes.
So on the supply side, they recommend that the supplies are selected between 550 feet per minute to 850 feet per minute with a design point of 700 feet per minute.
Okay.
So
Our velocity.
of velocity, yeah.
Okay.
And that's neck velocity,
Yeah.
right? So, so what you want to do is you want to go onto the performance data and you want to start in that 700 column and come down it till you find something close to your CFM.
Okay.
If you can't find anything, you can go to the left to the lower velocity down to 500, or you can go up to 800. And we really limit it at the 800 due to the sound.
Okay. That's a good point. We see numbers and we see ranges, but what happens when we exceed those?
Right. And so with higher velocity, you're going to have higher sound.
Okay.
And that's why the 700, it's up towards the upper end of the range.
Right.
But going down, you'll get lower noise, less pressure drop.
Yeah.
But that's not always good because we want velocity.
See, that's something we forget about.
Yeah, it is. It is. So, and don't want to get into all the science, but basically with the velocity coming through the supply grill,
right,
we create induction air. And what that means is we're inducing room air into the supply
into
air
the
stream.
mix. Okay.
And so what that does is it starts to create a circular motion in the room and we mix the air.
Right.
And then we let that mixed air come down into what's called the occupied zone of the room, which is basically floor 6 feet above, exterior walls 3 feet in, interior walls 1 foot in. And that's the occupied zone of a room. So we want to try to do all the mixing above that, outside that occupied zone.
And if we get too low, we like to make sure that we got low static pressure if at all possible. But if we get our velocity too low, how does that interfere with that circulation of air within a room?
So if you get it too low, and mainly when we're talking about this, we're talking about like in the air conditioning mode, the cooling mode. What's going to happen is that cold air is going to drop. Just the buoyancy of the air.
Oh, okay.
Okay. Cold air drops down, warm air rises. Right. So that's what's going to happen. On the air conditioning mode, that air is going to come out. It's going to drop. Somebody's going to feel a draft. They're going to get too cold. They aren't going to be comfortable.
Yeah. The science of airflow, once it gets outside of the ductwork. It's actually very fascinating. I mean, there's a lot to it.
Yes, there is. There's actually a lot to it. And trying to keep it simple, without all the fancy terms. So
let's say we have a lot of educators that'll be on the show, and definitely let us know where you're joining from. We have a lot of educators that are going to be teaching this in a classroom. So we'll have students that may have never even thought about a register outside of what they see or a grill. As a classroom, where do we begin? Where's the best place to start educating in the classroom?
That's a good question. I'd say, understand the types of grills and registers and diffusers that are out there.
Okay.
They do all kind of serve a different purpose. And by that we're talking about the face. With new construction, kind of the go-to product is a stamped louver face.
Do we have one of those with us today?
Yes, we do. In fact, we've got a few back here.
Okay, let's do that. Yeah, let's start doing some discussion on actual products so we can see the difference that we're talking about.
Yeah. So this one here is a one-way.
Okay.
And what it is all these louvers are stamped so that as the air passes through them, it's going to go all in one direction.
Okay.
This one is downward facing.
I'm going to turn this around so hopefully the camera can see inside with that.
Yeah.
Okay.
And then here is the lever for...
Lever or lever?
Well,
does it depend what part of the country you're from?
Yeah, I guess so, right? I was going to say.
Is it potato or potato?
Yeah, exactly. But yeah, there's a lever on the side here, and this is a multi-shutter damper.
Okay.
And so with the multi-shutter damper, so the multi-shutter damper, what it is all of the blades, and I'll see if I can get this so the camera can see it. All the blades rotate in the same direction.
Okay.
Right.
Yeah, I see that.
And so you know, what we do and with this multi-shutter damper, also known as a parallel blade damper, this will actually kind of change the direction of the air as well as it comes through the face, right? So, you know, when it's fully open, the air is going to come out. The louvers are going to direct the air in the direction of the stamp, right? And then as we close it, we're going to force that air even down further on this one way. Okay. And I'll tell you what, let's get a two-way as well.
Okay.
So we kind of see
That's a floor. But
no, that's it.
there's a wall. There you go. There's a wall.
So let me put this one up here for us. So this is a two-way. And again, if you can see it, this side of the louvers are going off to the right. Forward.
There we go.
Okay. I was trying to get the angle on it. And then these are going off to the left. So this is what's called a two-way, right? And then again, we got the damper on the back that we can open and close. And this is the one where, you know, not only are we going to be shooting the air out to the sides, we could be shooting the air, well, and we've actually got it upside down, but it goes like this. We'll shoot the air down, right, with those blades. Okay, and then along with that, we also have a three-way. And as you can see, as I'm grabbing these, there are different dimensions. So
Yeah, very much.
yeah, the other two were rectangular, okay? And they come in various sizes, right? And usually it's even sizes, 10 by 4, 8 by 4, you know, is kind of the standard.
Right.
And that matches the boot boxes as well, the part of the duct system that these go into. So this is a three-way. And if you look, the ones off to the side are going right, left. Then all these down the center.
Oh, all down the center go in the
going
same
one
direction.
Okay. Right? So we get three directions. And again, with the multi-shutter damper on the back. Okay. And then the last one we have is the four-way. Okay. And again, sides are going off to the side.
Right.
But now in the center this way, these upper half ones are shooting off towards the camera. And these down on the lower half are shooting off towards me.
Now, what would be the purpose of that?
So I mean, I don't mean to interrupt.
No, come on. I
don't
see
mean
you
to
aching
interrupt
over there.
the engineer. But, so you asked, where do you start?
Yeah.
When we're doing picking out a register, picking out a grill, where do we start? And I think before you pick the register and the grill, and this is will come to your question of when do we use one, is
right.
Where's the ductwork? Where's the opening?
Its location.
So it's all about the location of the ductwork. So in some applications, the contractor may come in and the ductwork is already there.
Right. Oh, yeah.
So now you have no
Majority,
choice.
right.
So now we kind of know. In a new construction application, now you get to pick and choose where do you want the duct to be. Typically in the United States, we like to do perimeter cooling. So we put it on the perimeter of the room, either in the ceiling or on the floor. And so in that instance, you're going to either do a one-way or a two-way.
Oh, okay. Absolutely.
Now, if you're doing in the middle of the room, you can do
That's
a
when
four-way.
you start thinking about where we want the air to go.
Correct.
Right.
And so you have so in this particular room, if this was a bedroom, because we're rectangular, you might just need a three-way. We put the grill over there, throw both these ways, and then this direction rather than do a perimeter down the length of the room.
Yeah.
So it really depends on where the opening is or where the ductwork is on what sort of register you're going to use.
Yeah.
Very good.
Okay.
Very good.
I mean,
You're absolutely right.
I mean,
Well, it makes
again, I
sense.
don't want to
With
jump ahead of the
location, right.
engineer.
No.
Yeah.
Because I'm just in sales. Nobody really. But yeah, that's the key is you got to know where the ductwork is. Ductwork is important. You know, it is one of those things that gets overlooked.
Right.
Sizing of the ductwork, you know, rule of thumbs and those sort of things. With the new equipment and the variable speed applications, now the ductwork sizing becomes even more critical.
Yes, it does.
And I'm sure we'll spend some time talking about variable speed in a little while, about how it was going to be the savior and fix all the ductwork problems, and really what it did.
Doesn't really do that.
It fixes one problem and creates another
Exactly.
one. So it's it's that whole thing. But yeah,
Sure.
so picking the ductwork, once you're there, then you can kind of go. Some parts of the country, everything is in the ceiling. And where we are here in Indiana and in the Midwest, typically the return airs are in the ceiling or high on the wall, and the ductwork, the supplies are in the floor.
Right.
So we do a lot of floor registers here.
Yeah. And where I'm from, California, we've got high sidewall,
All ceiling and sidewall.
sidewall and high sidewall. Yeah. So, and Donnie's absolutely right. I guess it does kind of start with where's the location of the duct opening for the supplies. Because if you're going into the ceiling, and again, if it's a hallway, for example, you may, if it's at the end of the hallway, you may want a one-way, just throwing down the whole hallway, right? If you're in the middle of the hallway, you may want a two-way. So it goes
both directions.
Both directions, right? So that kind of sets the throw pattern that you're looking at is the location. So
Yeah, because I think about like this 4-way. If this was installed in the center of a room and I was controlling where I was putting my airflow, there are times where a 4-way may not be exactly what I want. If my bed is in the center of the room, a 3-way I might be able to use to direct it away from the bed versus a 4-way I'm going to be going to both walls. So it really depends on that comfort and what you're looking for where you're distributing the air. How's it feel when it does make its way to those perimeters?
well, again, if it's in the center of the room, you really do want to use a 4-way because you want to throw the air out, and we're trying to mix the air above your head level, right? So you'd want to do that. But if it's off to the one wall, then you'd want a 3-way, right? Because we don't want to throw the air into the wall, because what's going to happen is it's going to hit that wall and it's going to come down the wall
back down
and create a draft. And that's when people get uncomfortable, right? We're trying to make the room air comfortable.
Yeah.
So, yeah.
I mean, that's what we're in business for. We move heat and we condition air. I mean, it's all about making things comfortable.
The air coming out of the register should not be felt. It's not a fan.
Yeah.
It's not a fan. The room should be comfortable without feeling the air move. And that's the trick. But what we've gotten into, and sometimes the application is just what it is. The ductwork's either undersized or oversized.
Right.
And now the velocity of the air coming out of the grill, and you can set in your lounge or your chair, and when the air conditioner comes on or the heater comes on, because you feel it hit you. That's not what you want. You want to feel the air should feel comfortable without feeling the air hitting you.
And that's a very important factor that we don't always discuss. And I think it's critical for us to consider that and to make sure that we're introducing that into our educational programs. Because when we think about what is comfort, we've said this word quite a few times, by definition, an ideal comfort is around 70 degrees Fahrenheit with a 50% relative humidity and a slight breeze. Not a gushing airflow across my face.
Right.
It's a matter of having that minimal movement.
Ken has some number. What's the number how fast it has to go before you actually feel it?
Yeah. So like ASHRAE kind of defines the air velocity as 50 feet or less is where the human body doesn't feel a draft. So, and that gets into, kind of jumping ahead of ourselves here, but the performance data and how it's shown that there's what's called the terminal velocities, and there's 3 of them: 150 feet, 100 feet, and then 50 feet. That last one is the farthest distance the air is being thrown from the grill. The 50 feet, and it's kind of not too intuitive until you really think about it, but the highest velocity is closest to the grill. So that's where the 150 feet is going to be. It's going to be the short number.
Right.
The 100 is in the middle, so it's going to be the middle number. The 50 is going to be the farthest distance away from the grill. So it's going to be the highest number that's listed. And throw is listed in feet.
Okay. Getting into some good numbers here. I was hoping that we would, because a lot of people don't think about that. We think about a register as, I've designed my ductwork, I'm going to throw a register on it.
Right. Well, what color is it?
Yeah.
That's really what we get.
That really it does.
What color is it? That's, that's the question.
Can I see inside or can I not?
Right.
Oh, yeah, we got some great questions came out. Thank you,
yeah.
Jocelyn. One of the science of grills really is fascinating. That's why we wanted to have this conversation. Joseph, we're grateful that you brought that up. So one of them that came in, please elaborate on that customers expect to feel a bunch of air coming out of their grill face. That's kind of a misnomer or something they've had in the past, wouldn't you say?
Yeah. It is. It really is. Some people, they think because they can't feel the air, the system isn't working.
Right.
And it's not, again, it's not that you want to feel the air. You want to feel the room is comfortable in that occupied zone.
Right. So there are 2 spaces that we live in as humans that we like air conditioning in the middle of summer. One of them is our home.
Right.
And then the other one is our car.
True.
Okay. So when you're in your car, you feel the air conditioning.
Yeah, it's all right in front of you.
It's right in front of you, like
a couple feet away from you.
And so what will happen is you'll get into the condition. Your body will say, "I need to feel the air on my face."
Right.
Cold air on my face or warm air in the winter, in order for me to know that it's actually working.
Yeah.
And what you should happen when you walk into your house is it should feel warm without feeling any breeze or any air movement. Or cool in the summer.
Yeah, true.
But what we'll have is homeowners will come up and they're like, I don't know if it's working. And so they will take and they will put their hand on the register,
Yeah.
right? And they'll go, I can barely feel the air coming out. So we will get calls. And the question is the room comfortable?
Exactly.
Yes, the room is comfortable, but I can't feel the air. That's great.
Yeah.
That's great.
That's a mindset to think about, really.
Right.
You know, and that is something that we have to confront, because we're not just teaching our students and our technicians to become, you know, good at designing systems. We're teaching them to be good at helping their customer understand how well things are now designed if we're doing it properly. Because I can remember when I first started learning airflow, when we were doing installations, when I first got in, I was a little guy, so I did all crawl spaces, attics. So
rat.
I was,
Attic rat. There
I
you go.
was. So I set
Love it.
a lot of ductwork, a lot of registers. Right. And one of the things that we always found, so we did a lot of custom homes back before the housing crash. One of the things I can always remember Bob saying was, if the curtains are moving, rethink what you did. Mm-hmm. And it took me a long time to understand what he was saying, because I grew up in that philosophy that, you know, it's got to be moving and it's got to be hot, or it's got to be moving and it's got to be cold. And that is not true. Comfort comes down to making sure that the air is getting there properly.
Correct.
The space is comfortable.
Right. And you know, and what we've done in the industry, going from PSC motors into variable speed motors,
right,
is we've introduced a motor who has the ability now to self-regulate itself at a much higher speed than maybe you need.
Right.
And so as you go to choke or, you know, turn down or close a damper, that variable speed motor looks at it as loss of velocity, and it speeds up.
Yeah, with the
and now
constant airflow.
And now you're like, uh-oh, I thought it was going to get less air, but now it feels like I'm getting more air.
Right.
But it's really just the velocity coming out. Noise can become
the noise
an issue.
as well.
Noise can become an issue at that point. So I try to remind everyone who I speak to, leave your vents open. You know, we're not dampering at the vent at the register. That's for back in the ductwork. But
yeah. You know, it was that one time I heard that there was a study done that closing off the dampers actually makes the system more inefficient.
Oh, absolutely.
Yeah. Right. Closing off a room. You know, a lot of times I know my parents used to go and, oh, nobody's in this room, let's close it all off. No, that really makes the system run inefficiently. You should leave them open.
Right. The only exception to that rule is unless you have the bypass damper or some drop zone.
Something that is designed for the airflow.
Otherwise, you're just pushing all the air down another vent, and not necessarily the way you want to do it.
Yeah.
I know there are various zoning systems out there and we're partners with one of them. That's what they do. You close either the damper in the ductwork, or you close the damper at the register. And, you know, what you're doing is you're saying that room is satisfied.
Right.
This room is at temperature, so we don't need any more air. We're going to run the other rooms for a little bit longer to meet set point. But eventually the system is going to shut down. That's what you want. Mm-hmm. Leaving it closed permanently, like the examples of we don't use that room, never put room in, never put air in there. That's bad for the system.
Yeah. You know, I spent quite a bit of time, quite a few years at the distributor level doing technical training, but also did a lot of technical support for one of our major manufacturers. And in that, I was able to learn a lot about that system capacity and airflow when we moved into our constant airflow blowers. And if we look at a modern high efficiency system, we're likely going to have an inverter outdoor unit, and we're going to have a constant CFM or constant airflow ECM blower. When we start changing the airflow, like say we start shutting those rooms off, you know, in the past, all we would do is just change that temperature differential. Now what we're going to do, we start reducing the airflow. The motor's going to recognize that. But if it has particularly like an electronic expansion valve where it's using temperature thermistors across the evaporator, measuring TD, what's going to happen is that inverter is going to start modulating back down because it's realized it doesn't have the heat load coming across the coil that it was previously operating at. So now we're going to start reducing capacity, like you had mentioned, simply because of that airflow. So another comment that came in from Lowell. Lowell, this is a great one. So Lowell said that his instructor, Tom, in a handwritten load calculation class stated the system should never be seen, heard, or felt.
There you go.
Exactly
that's
right. Perfect.
That's in the perfect world. That's it.
That's it. Yeah.
You know, I equate it to paradise. It's, you know, you go outside and 74 degrees and, you know, 40% relative humidity and the sun's out and you're like, feels great out here, but nothing's moving.
Right.
Yeah. Right. And that's the way your house should feel.
All right.
So
Where do we move from here?
So, and then I guess, let's just see if we can, let's,
So return air. So
Look at
this little fella.
yeah. So
I like this
we've
one.
been talking a lot about supply registers.
Yeah, let's
right
go to
now,
the other
right?
side.
So you got to get the air back to the air handler, back to the furnace, and that's why you use the supply or return grill.
yeah. So this one happens to be a return filter grill, and it's got these little finger latches
Where do you find the filter for that unit?
at your local Home Depot.
I love this. This is
Yeah.
a nice little sample piece.
So this one happens to have a removable face, right?
Yeah.
And so you can see here, let's set this down. You can see the frame here. This one's designed to hold a 1-inch filter, right? And so when we start talking about return air grills and return air filters, again, the ACCA, Air Conditioning Contractors of America, Manual D, have some recommendations. So when it's just a grill, and I don't have one here. There's that.
Yep, that's one. Yep, that's a long flat one there.
Yeah, this is a long flat one. But we got this. This is just a return grill, right?
Okay.
So on this, they say it should be designed for 500 feet per minute.
Okay.
Okay.
Across the surface.
Across the neck.
Yeah.
Right. Not so much the face, but the neck, the duct. Okay. And as you can see, it's just a flat grill. This one mounts flush against the surface, whether it's a ceiling or a wall. And the other thing to note on this one, these louvers, this is a 1/3 spacing. Whereas if you look at this one,
Yeah, I see a difference.
it's a 1/2 inch spacing, right? So with the 1/3, this is going to have a little bit more static pressure,
Yeah.
right? Because we got one more blade within an inch. We've got 3 louvers. Well, in an inch here, we have 2. So this one's going to have a little bit more static resistance. Okay. Something to take into consideration in your system. Get that out so we can talk about this filter grill. Now, again, ACCA, Manual D, what they do is they recommend when you have a filter grill, they recommend 300 feet per minute across the filter. Or the other rule of thumb is 2 CFM per square inch.
Yeah.
That works out to about 288 feet per minute,
Okay.
almost 300.
Yeah.
And that's kind of critical. The return air coming back, and again, we're talking about noise on just the grill. But when we're talking about filters, we want to maintain a velocity across the filter. Most filter manufacturers recommend a maximum face velocity of 500 feet per minute. If you get above that, what's going to run into happening, especially when the filter starts loading up with dirt, you could suck the filter medium.
Which happens.
It does, yeah. But you could suck it down the ductwork. So, and this one with the removable face, what makes this nice, this may get dirty because we're taking in dirt, right? You can take it off, take it outside, hose it off, clean it, bring it back in and relatch it, right?
Yeah. If you don't change that filter,
Yeah.
as it loads up, you will create a vacuum on the backside.
Yeah.
And if it's flex duct, you can collapse the flex duct. If it's metal, you can bend the metal in so that it becomes a noise issue. Keeping the filter clean so that you maintain the proper velocity is important. And depending on the depth of the filter, 1-inch filters, I tell everybody 1-inch filters is every 30 days. They're going to load up quick. 2-inch, you might go 60. 4-inch, you might go 90 days, but it really depends on your application. If you have cats or dogs or kids, or if you're opening and closing the door a lot, leaving your windows open less time, it's going to load up faster.
You bet.
Yeah. So, those are things to take into consideration with your filters. Now, the other one that's been happening is, the MERV rating,
Oh, yeah.
right?
Yeah. Anybody familiar with that? I mean, we talk about MERV ratings. We've had a couple shows on it. Not everybody understands exactly how that relates to air.
Right. So with MERV rating, minimum efficiency reporting value, as I believe that's what it stands for. What that does is it represents how much or how small of particles you're going to filter out of the air, right? So with a higher MERV rating, you're going to have a higher static pressure drop across the filter. Okay.
Yep.
So that's something to consider.
Oh, yeah.
And then the other one to think about is 1-inch versus 2-inch, right? With a pleated filter, the pleats actually add surface area to the filter media. So if I take a 1-inch pleated filter, MERV 13, let's say, it's going to have a pretty high, it'll have a higher pressure drop than a 2-inch MERV 13. just because of the surface area of the pleats. So that's something to consider. If you're increasing the MERV, you may want to consider going to a deeper filter.
Right. And the MERV rating, so it's I think they start at 4 as the lowest rating you can buy, and they go up to 16. Anything above MERV 16 is a HEPA filter, basically.
Yeah.
4-inch filters on the back end side of the return is really where you're going to get the biggest bang for your buck. You've got the most surface area and the lowest static pressure. Well, now, not to interject, but
good stuff.
RectorSeal does have a 17 that is pretty good. We will talk about it on another podcast. But
I want to hear about that one.
it has a point. It's a MERV 16 with a 0.2 static pressure, so it actually has the same static pressure as a 4-inch pleated filter.
And the other thing I want to say, with the filter depth, what you also increase is the amount of dirt that can load up in the filter, right? So that's another consideration. A 1-inch filter, it's going to load up with dirt faster than a 2-inch filter, and then a 2-inch is going to load up faster than a 4-inch. So just some more considerations when you start talking about your filtration.
And the higher the MERV rating, the more it loads up, because the higher the MERV rating, basically
Smaller
the smaller the
particles,
filters, the
they're
smaller
going
the
to
particles.
build on top of each other as they
not
go.
everything's getting through.
Sure. Absolutely. Another one came in. Very good question. I think probably not one for today's conversation. I know you're working on a return area in a hallway, and wondering if the 16-inch return would suffice. It really comes down to your airflow in your system. That's not even an hour show. That's a whole conversation.
That's a whole 4-day class on airflow design.
But we'd love to help you out with that. So we won't be able to put I don't think we'll have a chance to put it into the description here, but in the edited version of this, I'll make sure to put some links to some episodes that we've done on system design and on understanding the airflow and how to actually use a duct calculator to understand some of that airflow, because it will help relate even to some of our airflow restrictions potential that we have across our different types of grills and registers.
And I'm sorry, as I'm reading your note, it's actually a wedding hall.
Yes.
So let me just put this. ASHRAE has NC levels recommended for different types of applications.
Absolutely.
So when you look at this, you should start with the ASHRAE handbooks and look up the NC rating for that application.
Right.
A wedding hall, perhaps a church, it would be the same thing.
Sure.
And that's where you start with that. Make sure you're within that NC rating for that application.
Yeah, because if we're designing it for a residential application, or say we've been a residential technician all of our life, this is how we've learned, and all of a sudden we get into a new requirement, and it is going to come down to noise level when we get into these applications. We have to understand what specification is changing so that I make sure that I'm using the right calculations for it. And it really is going to come down to that. I mean, it could be a matter of understanding how the air is being returned and supplied into that space, and making the proper grill register selections could change things.
You're absolutely right. But, again, talking about the applications, when you're talking about your home, you've got a lot of soft surfaces. You've got carpet, you've got couches, you've got chairs. All of those are going to absorb the sound pressure, right? A church is all hard surfaces, a wedding hall, all hard surfaces. So the sound's going to reflect. So sound would be critical in that application.
Hope that helped.
Yeah, and it's also, like you were saying, you've got a lot of objects in the house. Once they're conditioned, right, let's say that they get to set point, well, they hold the set point, but in a large open area, you don't have a lot of objects in there. So you've got to turn the air more often. That's why typically in commercial applications, churches, halls like that, the cycle is longer. You want to turn the air more times because there's not anything in the room to hold the air. And you typically in your house, you don't go from nobody in the room to 150 people in the room.
Yeah.
And now you really have introduced a heat load in there that needs the air to turn quick.
Yeah.
Otherwise, everybody's going to be in full on sweat before the air conditioner can catch up.
I just want to tell you guys, we are moving energy. Okay?
Yes, yeah, we are. Yeah, we're moving from
heat energy.
Yeah,
we are in air conditioning mode. We are removing heat energy from the room.
Right.
So you guys
exactly.
You guys talk about no, we're moving heat energy, guys.
Yeah, we're moving it. You don't move cold.
Yeah.
You move heat.
Exactly. We're in the business of moving heat.
Correct.
You
move heat.
Either in or out.
Right. One way or the other.
Joseph, I'm so glad that you joined us today. So Joseph says, you guys are going to appreciate this because he's of our own interest here. Thank you guys for giving me a safe place to nerd out on airflow. Yes, we are a bunch of airflow nerds, Joseph. It says you guys rock. Hopefully, you can catch you guys on the next time. Joseph, every week we do this. We have a live show every Thursday where we bring in our top educators, primarily manufacturer educators, the ones that are working with these products, engineering these products, selling these products every day, that are understanding the pains that you are witnessing out in the field. So we encourage you to join us. We do a podcast every week as well, and I'm sure we're going to spend a lot more time with RectorSeal, getting to know products and diving into the educational side of products, which is really important for me. That's why we love partnering with manufacturers that are so passionate about education like you are, because it makes the entire industry a fun, a better place to be.
Right. It raises the level of the industry.
It does.
One of the things that we haven't touched, and then we're talking a little bit about the return, is the static pressure. We talked a little bit about static pressure early and how closing the vents and maybe sizing it various directions will increase or lower the static pressure. What we do when we start with the duct design is you want to make sure that your return is slightly larger than your supply.
Never forget that.
Right? I mean, if you're new to the industry, you'll never run into an application where the ductwork is undersized. That's never going to happen.
I agree.
Facetiously, right?
Like most applications.
Almost every application. When they say it's not working properly,
right,
it's almost always a return problem. It's not a supply problem.
And that's what I was going to add is, when out in the field, if you have this airflow issue, one of the easiest ways to improve it is on the return grill. If you look at this, a stamped louver, right, you've got the center strip. And if this was bigger, we'd have more center strips. Right. There's also what's called a fixed bar grill, okay, which is, we've got one back here.
Right there. Yep.
Oh, yeah.
And
it's a good looking unit.
This is thank you. Yeah, exactly. So, and this is one of these that I've taken several calls over the years from people. They complain about the return air grill is whistling.
Yeah.
And really what it comes down to is free area. How much free area does the grill have? Okay. And if you run into this where homeowners complaining about a whistling grill, easiest thing is to do is change out that stamped louver and get a fixed bar, because these bars will run basically the whole length of the face. Minimal restriction. Depending on the grill size, you may have a center support, but it's only going to be a 1/4 inch. It's going to be bent. It's going to be a little more aerodynamic, right? But less static pressure, higher airflow through this. So again, talking about that whole return, one of the easiest ways to help correct the static pressure problem, change the return grill. But, the other one, of course, this is a fixed bar.
Right.
We also do have, where is it? Oh, I had it right. Oh, there it is. As we're moving our samples. We have the supply, which is an adjustable bar. And these bars can be adjusted. And so the air can go out like this, or it can come straight out. Okay. And again, we've got the multi-shutter damper on the back, right? And again, here with the bar, the adjustable bars, these are all individually adjustable. We have more free area. Again, less restriction. The stamped louvers are kind of the builder grade, if you will.
Yeah.
Whereas if somebody's going out to a house, and if you're replacing a system, the one thing the homeowner sees day in and day out are the grills and registers. If you want to make an improvement, change out those old stamped, what are they, $10, $15 each? So maybe you're adding $100, $200 to the job cost, and you'll improve airflow performance. You'll improve the appearance for the homeowner. It's a great way to do it. So, and I will say with the True Air product.
Yeah, you were talking about this earlier. Let's go into some of the benefits here.
Yeah, so True Air, one of the things that they do is they have our smooth glide technology, as we call it. Mm-hmm. And what we do is we paint all these individual parts separately prior to assembly. And then we assemble it. And you can see right here, the rivets are all zinc coated so they don't rust. But right out of the bag, you've got this smooth operation. Almost all the other grill or register manufacturers, they assemble and then paint. Okay, when they paint, these blades are typically closed, right? And so you've got to first open it. You got to break all these pivot points. Sometimes the blades, when they touch back here, they'll actually kind of glue themselves. And so you break it. Now, not only do you break it, but it also creates a little bit of rattle because you're breaking that paint, you're chipping it off. It's not as tight. And then all those bare spots are going to rust. And then it's going to start, locking up, and it's not going to work that well. So that's one thing that True Air's taken the time to do. Like I said, we call it our Smooth Glide technology.
There's nothing worse than a rattly register. At least for me, and I'm kind of particular on sounds. So I can always tell when there's a cheap product in an installation just walking into the area.
Right. Noise is one of the number one complaints associated with HVAC. It's not the brand or the size or the cooling capacity. Homeowners complain about the noise. I hear it coming on. I hear it going off. My grills rattle. It's loud. They don't like that. This is a product here that takes care of at least the rattling of the grill.
Yeah, and
the undersized ductwork we can work with later.
Yeah. True Air, we have a saying: no rust, no rattles means no callbacks.
So I like that. That's a good one.
Go put in a $10,000, $20,000 system, and you got to run a truck out there because you got a rattling grill, a $10 grill that rattles. So
makes a big difference.
Yes, it does.
Had some other great comments. I'm telling you what, the group is really enjoying having you guys with us today. Very helpful for the ratings. Definitely got it. Lowell, thank you. MERV ratings on the institutional scale. We were using box filters, bag filters, and standard 2020 22s. And yeah, I think these already picked up some ideas of things to go back and relook at. And Lowell, his motto is air is king, ventilation is queen. Great session. Would like to see more on the air side. Yeah, and it is. On the air side, troubleshooting is becoming so important in our industry. And a lot of it does have to do with our high efficiency equipment. These ECM motors, when we looked at PSC motors, they trended the same all the time. Their permanent split capacity had a very standard curve to it. When we went to ECM, we went to two different styles. We went to a constant torque and went to a constant airflow. Yeah. Both of them respond differently to external static pressure. And one of the things that you hear from the industry that is so incompletely wrong is that ECMs overcome static pressure, and nothing overcomes static pressure. The only way to make a system run properly is to understand the static pressure, reduce it when possible, but understanding what are we doing? What are we actually changing when we make these airflow adjustments, and how does it make our system perform differently? Right. It's huge. Yeah. Airflow before charge is one of the big things in the 100%, industry. 100%. And here we're talking about airflow, and people aren't even thinking about, well, sometimes it's a matter of maybe the duct was already designed. Maybe it was a poor selection of grills, registers, and diffusers.
Right. Yeah. So one of the things that I used to do when we would teach contractors service. So if you're a service technician, you're going to a house on a no cool call, right? So typical industry standard is the technician leaves his truck, he grabs his gauges, he goes straight to the outdoor unit, and he puts his gauges right on there to check the refrigerant charge. That's probably not the problem. So we taught everyone, go in the house. First thing you're going to look is check the filter. And, and the funny thing is, they're like, hey, when's the last time you changed your filter? And then the homeowner says, this thing has a filter, right? So you have a problem. But
my spouse does that.
Exactly. Yeah. So you change the filter, and then you see if the system responds. Then you check to see if they've closed any ducts. Are the vents closed? Is the system breathing properly? Then we can go and find out if it's charged properly. That airflow is king. It is, and I don't know who it was that said it, but that's the thing you check first.
Yes.
Yeah. Yes. So you check that first.
Absolutely. And you're absolutely right about the dirty filter. I mean, that's number one. My wife and I, we live alone, but we have cats. Yep. I change our filter religiously at like 2 months, if not even sooner, because of the cat dandruff. If you have dogs, dandruff. You got kids running in and outside. They bring in a lot of dirt, a lot of dust, so,
Kids are filthy little animals.
Yes, and we continue to have them.
And we were all
What do we do?
one at
That's
one
right. Well, this has been a really great conversation. This is the first time we've had a chance to sit down and do a show together. I could really see us doing more. You have so many products. There's so many toys in this room that we're just not going to be able to get to them all today. But I promise we'll come back and we'll do some more as we continue having these conversations about performance and about training. And so tell me a little bit about different training opportunities that could be available through RectorSeal.
Sure. So we have a broad line of training that we offer online. So we got several different ways you can do it. You can log on to RectorSeal.com and see pre-recorded, pre-canned training, basically self-paced. You can watch the videos, follow the PowerPoints. We've got on-demand training. So if you are a technician or if you're a contractor that wants to get their whole entire service department trained, you pick a product category. Maybe it's GRDs, maybe it's surge protection or whatever. You can pick the day that you want to do it. You can pick the hour that you want to do it. And if the trainer is available, someone hasn't beat you to that time spot, then you make the reservation and the invite goes out to you. And then it's your private training, just yours. And then periodically, 4 to 8 times a month, we will send out blasts to our distributors to say, these are the topics that we're doing on these particular days, open to the public. Anybody can log in and register for those. So training, I think we were talking prior to going on live that, training was one of those things that before COVID, we would run around and fly across country and do a whole lot of things. And then COVID hit.
Technology has changed
and then everyone
things.
developed a camera and we were able to do things live via the camera. Post-COVID, we still do some in-house training and go do some personal training, but the live and the training on demand is really, really picked up. Now, Ken does a whole different point of segment training because he's training engineers and large mechanical contractors on these topics.
Yeah, and usually commercial product. Talking about our two different brands. True Air is known for their residential products, and they have some light commercial. Our Shoemaker brand, they are more of the upper end for residential, linear slots, things like that, and then commercial product. And that's where I go out and I do more with the contractors and the specifying engineers and do the commercial.
So you're doing training for residential and commercial applications.
Correct.
Very nice.
So above and beyond what RectorSeal does, what we also do is we train our distributors. So we have distributor partners around the country that we train. So some of them have their own training facilities. You've probably been to a few of them, right?
Absolutely.
And so we'll get in there and we'll help them set up their own training, and now they can train on it. And then beyond the distributors, we have sales reps that we employ that cover the country,
right?
Because I can't go everywhere. I cover 13 states, and I can't get to every location.
But they want us to.
They do.
We can do it.
Everybody wants to have
That's
me
right.
there. That's for sure. So, but we employ independent reps that we get trained up, and then they are able to go out and do some training. So
fantastic.
We talk about training a lot inside RectorSeal. We want to make sure that the products are installed properly, and that people understand what's happening. And if we're talking about grills and registers, that they understand misapplying the grills and register can affect other things. Like you put the wrong register or the wrong grill on the product. Well, now your air handler or your furnace is affected. So now you've made a problem. You've created an issue. We don't want that to happen.
Yeah, we actually just had a comment very similar to that from Katie Donahue. Katie, how's it going? Katie's been with us since back in the Johnstone days. That she's been following, learning, started out as an adjunct, now as an instructor over at Jefferson College. Katie says check internals or externals before internals. That's really what we're here to do is talk about the externals that will affect the internals of a system.
Yeah, you don't go to the doctor. They don't cut you open when you first go to the doctor. They take your temperature,
check some things,
right? And then they cut you open.
Right? No, you're like Howard. We have this conversation all the time, and Howard says, in HVAC, the HVAC professional really in today needs to understand their value to the world around them. We serve a very professional career. We serve one of the careers that was recognized as vital during COVID. And would you feel comfortable going to the doctor and he looked at you and said, yeah, I think you sound a little off. Let's go ahead and start cutting on you.
Yeah,
right?
No, thanks.
No.
Yeah.
So there's a lot of education. There's a lot of opportunities to learn. And I'm grateful for this opportunity. You'd mentioned, even working with your representatives. That's how we got here.
Yeah.
Chris May's with us today. She's the one that made the arrangement and said, "Hey, you need to spend some time with RectorSeal. They've got some really high quality training on GRDs." And I'm like, GRDs, what is microprocessor? They're like, "No, girls register diffusers." I'm like, now we're cooking, because that's not a topic that we tend to go deep into very often, and we should. It's as vital as that ductwork that's getting the airflow into the spaces.
Correct.
Yeah, absolutely. So
Excellent. How we doing, Jocelyn? All right, time wise. Oh, okay, getting right to the end. Oh, yeah. All right, well, this is a good time. Let's get back
Nice
to our
segue.
raffle. All right, so tell me a little bit about these products. You guys familiar with these products very much at all? I know I've seen them sitting over here, and I don't know them very well. I've seen them. I've not had a chance to use them myself.
Yeah, I will tell you about them. So this is the one. So this is the flare fitting. So when you're doing mini splits,
Yeah.
typically the inline of the refrigerant lines need to be flared. So this is a product that uses a hand drill. You got it? Open that bad boy up. Comes in a nice case. So you'll take the bit here, and this size happens. I think this is half. Yeah. So this is 1/2 inch. So you'd put that in your drill, and then you would make your nice cut with your tubing cutters. Deburr it, make sure it's nice and smooth, and then this just goes in. If you notice, the top of it's a little inlet,
it's tapered.
so it will rest inside the pipe. When you turn the drill on, when you pull the trigger and it starts to spin, it will create heat. And what that heat will do is make the copper more malleable, and then this will quickly just sink in. And at the bottom, it has a little flare, creates a flare, and now when you pull out, the flared fitting is on the copper. Now, the difference between doing it this way and just using a regular flaring block is with the flaring block, you're cold flaring.
Sure.
And so you get micro fractures in the copper. This is as close to annealing the copper as you can get. One recommendation. So if you're right-handed and you hold the drill with your right hand, your left hand is going to hold the copper. Have a glove on that left hand.
It's going to get warm on you.
It's going to get hot on that. No, it's not going to get. It's going to be hot.
Okay.
And I've seen grown men drop their drills.
In the process.
On the process of doing this. Have a glove on the holding hand of that piece of copper.
So that's the winner,
the flaring tool.
Note to the winner of this: it might come to you slightly used. Just saying. Just saying.
Yeah. And then
might have to try it myself.
So this one is the same design, same setup, except now we're just doing a swedge. So a swedge is useful when you're taking or combining copper, or maybe you've had to cut the copper loose and you don't want to have to use a coupling. So what this will allow you to do, and you notice there's no flare, there's no bell at the bottom. So this is just going to go in and it's just going to bell it out.
Same concept.
Make a swedge. And now you can take the fresh piece of copper and put it inside the swedge. And now you just have one brazing joint.
No coupling.
Right. No coupling. So couplings have 2 brazing joints. This is 1 brazing joint. I will say this, a little, useful information. When you get done brazing this, the copper will be hot. It's also going to be expanded. If you take your cold piece of copper and put it in there immediately, the hot copper will cool down and it will shrink a little bit. It will, and then your brazing is way easier because it's not falling apart. Really, really useful tool, especially if you're extending line sets or you've got to cut a compressor out or whatever you've had to do. Nice set design here, and it's really hard metal too.
Awesome. Might also come slightly used, near new. But if they are slightly used, there'll be a demo video available for you coming. Well, Ken and Donnie, I'm sure grateful that you guys hung out with us today. It's so nice to be able to get out on the road. That's what we're spending a lot of time doing now. Thanks to our sponsors. We're taking the show on the road. We're getting out with our manufacturers. We're at the distribution center here in Greenwood. You've got distribution centers all over the country. So there's a lot of opportunity to get to know RectorSeal better. Where can people learn more about RectorSeal?
So RectorSeal.com, or you can reach out to your local distributor or your local rep. With any questions, go to RectorSeal.com. There's a comment section in there. You can type in your questions. Like you said, we do have, I think we're up to 9 distribution centers. With the acquisition of Mars, which we just closed on recently. So now we have motors and capacitors and all sorts of things to talk about.
A lot of new training.
Yeah, a lot of new tools and fun toys to play with. So I hope we get to come back and talk to you about that in the future as well.
Yeah.
Look forward to it.
I'm sure we will. All right. Thank you all so much for joining us once again on Did You Know, the ESCO HVAC show. Make sure to come back next week. We're going to be talking about some refrigerant regulations that change the first of the year that you may not be aware of. So everyone have a wonderful evening, and we'll see you next week on Did You Know. Bye, everybody.
Bye. Bye.